Good afternoon, everyone, and welcome to today's NCLUG Tech Talk from Bentley. Today's webinar is focused on OpenBridge Designer, workflow, and bridge creation. As an overview of the latest updates to OpenBridge Designer. First, some housekeeping details I'd like to go over before we get started, so you know how to participate in today's event. Because this is a presentation, all attendees will be muted. At any time during the webinar, you'll have the opportunity to submit your questions to today's presenters. To do so, just type your question into the chat box. As time allows, the presenters will address as many questions as they can during the Q&A session at the end of the presentation. We will be recording this webinar and will share the link after the event. NCLUG is offering PDH credits to those who have registered on the website for this event. If you were forwarded the meeting link, you will need to make sure you're registered on the nclug.com website. After the session, NCLUG will send out PDH credits to those who attended this live meeting. Credit will not be given to those who view the recorded presentation. As of this meeting, PDH receipts have been sent out through our September 9th Tech Talk. If you did not receive PDH credits for a meeting you attended, please email us at events@nclug.com. Also, stay around till the end of the presentation because we will have a drawing for a $50 Amazon gift card for one NCLUG member. You must be online at that point to win. And now I'd like to introduce Alex Maybrich. I hope I didn't butcher your name, Alex, of Bentley as our presenter. Enjoy.
All right. Well, thank you. Let me start presenting my screen right now. So you will be seeing my desktop at any minute now. So let's start. All right, perfect. So as you see in my screen, the title of the presentation is, what are we trying to do with all this 3D project delivery, right? And the idea for most DOTs now, as they're moving to this 3D work, basically, right, is just to go and say that they want now for you to submit this, right? That's the end goal, right? A full 3D digital project delivery. Yes, there are plans that need to be maybe added to that 3D model. Some DOTs are more ambitious and they're saying planless projects, right? So again, at the end, that is the final goal. And for Bridge, for us, the tool to use is OpenBridge Designer, right? The idea is to use OpenBridge Designer to create with what we call a common data environment, right? In which the file that we use is not an external file or a new format. Actually, what we have done is with OpenBridge, we have what we call our common platform. As you know, with Open Roads, OpenBridge, Open Building, it's MicroStation. So when you deal with OpenBridge Designer, you will be dealing at the end with a DGN file. So no format change, is just more information. And if you need to bring information, alignments, profiles coming from Open Roads, it's just another DGN file that we can read. And if you're designing your bridge and well, you need to see the corridor, just reference the file and it will just access that information for you and you will be able to visualize it as well. So that's the idea for that. Right? Now, again, what we're trying to do, or what you will do, is that you will be creating what we call a physical model. So the one at the top, it's what we say, it should be the exact representation of what the bridge is going to be at the end in the field. You are going to get it in your computer. You are going to develop that in your computer. Now, in the meantime, of course, you need to calculate the bridge, right? So from the physical model, you will be able to generate an analytical model to do your structural calculations. And this model could be wireframe, it could be a grillage model, it could be a frame model, it could be a finite element model too. So, but with OpenBridge Designer, it all starts with the physical model. To understand a little bit better the process, let me show you how we do bridges now, right? Before all these 3D, all this OBD or OpenBridge Designer. And that's what we call a disconnected workflow, right? Why? Because when you get a bridge project, the first thing you do after the TSL, right? Deciding what bridge type you're going to do, where it's going to be located, what size it's going to be, you just go and say, okay, I need to calculate the bridge to see if it works. ASTO 3, ASTO 4 beams, 3, 4 spans, and then you just generate an analytical model, right? You use whatever method you want to use, grillage, finite element analysis. When the bridge works, well, you generate reports, right? Moment diagrams, shear diagrams. You just finish the structural project. But then this project needs to be represented into plans, right? So how you transfer all that numerical information that you generate, all that schematic information that you generate, well, it's a manual process. And this manual process then goes back into 2D plans. You start 2D drafting, copy paste from all plans, modify elements, right? So all the fine calculations that you have done using finite element analysis to the 16 decimal places, it goes back to feet and inches in a PDF document, right? And when you're going to measure quantities, you measure quantities, measuring sometimes even from the plans, rather from the CAD files. You put it all together, you create a plan set, and this plan set, through another delivery process, is sent to construction. And in construction, a lot of stuff changes, right? A lot of requests for information. I'm based here in Florida, we call it RFIs, right? There is a conflict on the bars. There is an element that doesn't fit where it's supposed to be. So a lot of requests for information, a lot of changes. As-built plans are delivered, annotated on the plan sheets, and then when the process is finished, construction is done, all of that is just sent to a shelf until next time a repair is needed. So that is what we have been doing for the past 25 years that I have in practice. The process hasn't changed much. We use different tools, but the process is the same. What we're doing now is what we call an integrated workflow. As soon as I get the project, I create what is called the physical model, right? As I said before, the exact representation or the closest representation of my bridge in my computer of what I'm going to construct on the field. From that physical model, I said, through an automated process, let's calculate the bridge and see if it works. Place ASTO 4 beams, see if it works. If it doesn't, change it to ASTO 5 maybe, for example. And then if it works, so then through another automated process, my physical model is changed. So now the ASTO 4 beams that I had now become ASTO 5 because you know it works. From that physical model, right, since I'm reading information, geometry information from different sources, survey, sorry, I was muted somehow. So that 3D file becomes, I extract that 3D file, that physical model, and from that, I just generate my set of plans. I generate my detailing. I generate my deck elevation report, beam seats report, beam elevation reports, pier reports. As I said, the physical model is reading geometry information directly from alignments, profiles, super elevation. So I don't need to compute anything. It's just a matter of reading and extracting the information. And if I need to produce plans, I just cut the plans from the 3D view, right? Think about it. If you got a 3D model of your bridge and you slice a cross section, what do you have? A typical section. If you have the 3D model of your bridge and look from the bridge from the top, what do you have? A plan view. You look it from the side where you have an elevation view. So you can compose a plan elevation sheet that we need to do. Then, having the plans, but also the 3D model, you can send that 3D model to the contractors, and they will be able to build and see the design intent that you have in your bridge. Not interpreting your plans, actually seeing the 3D model and building that. That is what we are doing. That is what we call the integrated workflow. And we do that through OpenBridge Designer. So in OpenBridge Designer, we have the modeling tools, but as well, we have the analytical tools to calculate your bridge. So you model here, and then you send it. I'm not saying export. You send it to LibBridge Concrete, LibBridge Steel, or RM Bridge, depending on the type of bridge you have, right? So if you are familiar with LibBridge or the old ConSpan RC Pier, you still have it, right? So the learning curve, if you already use these softwares, is minimum. What you need to learn is, as I said, how to model the bridge in 3D, how to do this. Right? There are many ways to do it, many tools that you can use, and then you can achieve what I said, this, maybe even render it with the tools that we have inside OpenBridge, like Lumen RT, and generate not simple bridges, but even the most complex geometry could be entered and generated. Now, the 3D modeling tools that we have allow you to generate these type of bridges at this time. Pre-stressed girders, steel eye girders, segmentals, casting plate boxes. Model that in great detail, and as well modeling the substructure. Substructure that could be, I would say, simple, or could be sometimes quite complex if you need to. So that's all you can do. Now, going to the workflow, and then let me switch to the software itself, right? You know what we are trying to achieve here, right? So, well, let's do it for real. Let me start OpenBridge Designer. So as I start that, you will create what is called an OBDX project, right? I already have one. So I will open that. So it's a matter of creating file new. And in that OBD file, right, you should be able to create a new project. So this OBDX will contain all your bridges, right? So if you have an interchange or a corridor in which you have 10 bridges, maybe 10 different designers, all of them will be able to access this OBDX file and work independently in each type of bridge, right? So it's just a matter of saying, I need to create a new project or a new bridge, I-595, for example, bridge 1. Done. So the project will be updated. And then here you say, I need to start modeling. And that's when you open a DGN file. Right? So now here in this project, I have many different bridges accessing different types, different DGNs, and even different types of bridges. Right? So designer John Smith could be working here, and I could be working here. Different DGNs, but at the same time, all being managed by the OBDX file. So saying that, that's it. Let me start from scratch. And I have this file there already. And I'm going to access the modeling part, OpenBridge model. The workflow, it starts with a 3D DGN file. So here I already created a DGN that comes from a Sept file. Right, that's it loading. It's loading on my other monitor. Right, so let's wait until it loads. Right, this OBDX file for the ones that use ProjectWise is also compatible with that. So it's a matter of placing this OBDX in ProjectWise and all the other DGNs that you have here and manage. So it will all be there. It works with the managed workspaces. So your standards will be loaded automatically as well. And well, the file gets loaded. So let me move it from my other monitor as it comes about. Here we go. Right here. Okay. Now, why it comes like that? Because I already, just to save time, I reference the corridor information. Right? I reference the geometry center line already. So these are all live reference files from the roadway project. Now, how do I get this image? Well, this image, I get it from big maps. Because I took the advantage that I know that my project is geo-reference. How do I do that? Because I can go to, it will be to the drawing part here, and in drawing aids, I can have, here, the coordinate system, right? So I know where this project is located and what is the coordinate system that is using. As soon as I attach that, automatically and free, Bing Maps gets loaded and the background map shows up in many different forms. Right? So that is the extra work or the pre-work that I did for this kind of design. Right? As I said, this is a 3D file, so I just able to move it and rotate it, right? Just, but tell you the truth, for me, it's easier to work in top view, right? So I will be doing 3D without doing 3D. What else? In OpenBridge Modeler, I have different workflows. And these workflows are the OpenBridge Modeler per se, right? So in which I want to be using the tools to model, of course. But then I have ProConcrete workflows, so it means that I can place reinforcement on my bridge if I need to. And in the latest edition of OpenBridge Designer, yes, we can incorporate your boreholes coming from GINT. And if you just want to do plain drafting, just want to use OpenBridge Modeler as MicroStation, here you go. That is your MicroStation right here. 3D modeling tools and visualization tools like LumenRT is included into OpenBridge Modeler here. So let's go here, right, to the OBM workflow. Now, let me zoom to the area of the bridge right here, right? And I'm going to show you the new development, right? I can go step by step and create a bridge, place the piers, place the deck, place the pier and the abutment, and I should be done. right? So I can do that. That is, I would say, our normal workflow. Now we call it the long workflow, and you will see why. And when I place deck or I place pier, I will use a predefined library of
Hi,
elements.
this is David Betty.
Please. All right. So then, for example, this predefined library of peers. So you can create this library. We provide it to you as well. A lot of DOTs are creating these libraries as well, right? And then here, for example, I want to place this type of pier. 3-column pier, right? And all these dimensions that you will see, I can change it, right? It could be maybe a little bit more elaborate. And then I can use that for placing. So just remember these names, right? Now, if I have a library of abutments, same thing. So I'm doing a design for maybe Virginia DOT. So that's the abutment type that they use. And then I will be able to place it. And we got libraries that you can modify. You know, I can go and edit here and say, well, look, I need different dimensions. So maybe on this abutment, I don't need 50 feet. Let me exaggerate so you can see how we change automatically. So that's it. I got 100, right? Or I got 60. And this, actually, you are modifying a 3D model, a 3D template, without knowing anything on 3D. So you can create your own set of libraries like that for different elements, not just, as I said, piers, abutments. You can go with barriers, as we have, for example, myself, we created the Florida barriers for us, right? So these are the Florida barriers that we use. And these are all part of the workspace, so you can just use it, especially for the decks too. Right? And then you just generate it and say, well, this is my deck. And that's what I'm going to use. Right now, this deck, it's variable because we put it into variables. So right out of the box is 20 feet and 20 feet. So it's a 40 feet deck. But if I need 60, I just change the number and the deck just widens. If I bring the information from open roads, then I activate the super elevation. So I can read the super elevation and adjust the deck automatically with the super elevation rotation that is happening. Okay, so we can define all these templates. So now let me show you the new development then, in which I will create the bridge using the bridge wizard. So I activate the wizard. It comes about. And well, here we go. I'm going to create bridge 1, right? And it's going to be concrete, pre-stressed girders. I will use this alignment that it was given to me by Open Roads. So I select the alignment. It recognizes the alignment. That's what it's called. And then I need to pick the beginning station of the bridge. Let's see, that is this one, 30 plus 60. Done. Remember the templates? Well, that's when I pick what deck I want to use. And how many spans do I have? Well, let's try on this bridge. One span of 80, one span of 130, space, another span of 130, and another span of 80. Right? Easy to understand. Or I can do, maybe I'm a little bit more sophisticated, and then I can say one span of 80, two at 130, and then another one of 80. Skew angles. I need 5 beams at 8 feet separation. And I want to use for that a template of an ASHTO beam, and let's do an ASHTO 5. Select it. Do you remember the templates? Well, let's pick one template, just one, we can pick templates for the abutments, templates for the barriers, but let's pick a template for the period. Let's use that one, right? And the same, I can pick a template for the abutment too. Place a barrier. So again, one more time, pick a template for that. And I know the station. That's it. Then just wait until the entire bridge is processed. So it should take maybe 1 more minute. I think not even that. And there you have it. And it's a full 3D bridge on what you have. Done. But maybe this is not what you want. Maybe this is trial and error, right? This is not the configuration that I want. These footings are too close together. Maybe I should change it to a combined footing. Maybe I should change the dimensions of that, right? So even though this is created already, fully automatic, as you can see, you got the options to change it. All this information is already stored in your DGN file. If I go to Explorer, I can see that I have created bridge 1 using the 72 EB alignment that I selected, and I have all these elements ready to go and be able to modify it. Then I can just check the properties of Pier 1, for example, and all the information there, right? But then let's see, this is not what I want, right? I wanted combined footing. So let's do that. So I just select it, and I say that I want to change what? Oh, I want to change the actual template itself. So go and select it. All these dimensions are okay, except for my footing that I want it to be not a rectangular isolated, but a combined footing. Done. Oh, but the depth, I want it to be more. Let's do 60. So again, you can see the difference. Done. Oh, but the piles. Let's change the piles. So I need a new setup of piles, and I knew that I need a new pattern layout because this is not going to do it. So I just say that I need maybe 4 columns of piles like that. Control their separation, of course. Done. And then this new configuration, I can save it into my library, so we'll be able to access again by templates, or just say this is a one-off change, so I'm just ready to accept it. And I'm good. And I can start changing more and more information here. This abutment too. Actually, this abutment, I'm going to be a little bit more ambitious and say, no, I don't like this abutment at all. I want to change the template completely because I want to switch it to maybe a batter piles. Select it, okay. Done. Then I have options, of course, to change the display, to render it. So I got a full 3D model with all geometry done. Now, I'm tying perfectly with the corridor, of course, because I'm running with their profile. They give me the right bridge limits, and then I can modify it if I need to. Right? But more than that, all this information is real geometry. So the big advantage of that is when I go to analysis and reporting, I can go and say, I want deck elevations. And on deck elevations, I need to specify information, right? Like what are the deck limits? So on that, I rely on the support lines that I place, and I say, I want from here to here. Accepted, right? And now look at the 3D model here, because I'm going to say that I want a consolidated report of 10 points along the left and right edge of the deck and along the beam path, every beam path, so I got 5 beams, remember, and also along the alignment. Generated. And these are the points where that information is being extracted from the deck. So it's reading from the deck, and these are your deck elevations in consolidated form. We can do a station offset elevation too, but this is kind of a cross-section look of every element along your deck. I remember that we used to do that in Excel, right? Trying to put the geometry of the alignments and profiles and cross slope on there. Now it's just, as I said, reading the 3D model. And still, you can export here to many different formats. So you can still use Excel for the ones die hard on that, like myself. Right? So you can export that. Right? So what other reports you can have? Remember, we just not just place geometry elements like cylinders or prisms, right? We know that we're placing concrete beams, right? Concrete piles or steel piles. So I can also request a quantity report. And it's going to read the bridge and say, go for it. So it's going to detail every single element that I have and give me the quantities from it. And where these quantities came from, what is this unit price, or why would I have these materials and that dimensions and even that cost? Because in the library that I can define, I can also define a material library. And say, this is the material that I'm going to use and assign to every pier, to every footing, to every column. And these are the specific way. This is the unit price that I have for English or metric. And also I have some physical properties like Poisson, resistance, modulus of elasticity. Why? Well, because if I use this right, and I have my bridge fully modeled now, and you know that you can extract quantities from it and get beam reports and so on and so forth, I can also say, even though I think this should work, I can double check and send this bridge for being calculated, right? So following that workflow that I showed you, that beam workflow, I said, I need to calculate this bridge. So from this physical model, we will extract an analytical model, right? Just enough information to design this bridge. And in this case, this is a pre-stressed girder, so we will go to lip bridge concrete. Yeah, the lip bridge concrete that you know, the corner span, the RC pier, is all part of OpenBridge Designer, so you don't need to remodel it again. You just need to design it because the geometry is already done. Right? So what you need to do is just use the, excuse me, the corner span. I'm sorry, it's not called corner span anymore. It's called pre-stress girder, right? That you know, and add the geometry. The materials, remember that physical properties that I told you about? Well, these are already filled up. right? And then you just need to go and just load. Hey, they're already done too, right? So it's just a matter of just verify the factors that you use, the design parameters that you use for your specific DOT, and then just run the analysis for all the limited states, and then pick one beam and try to design it and see if it works. Not bad, right? So I can just say copy that to all the span, all the beams, and see if it works. And it seems to be working. So then you can continue with the pier and the stuff, right? And then just send it back all that information to the model. So then I know that my bridge work, right? And then maybe switch to another DGN file and try to see if it still works. Or maybe I can use another span arrangement and try with steel and analyze the cost with it. So I can do all of that. Now, in BIM or in 3D terminology, you should get familiar on what DOTs are asking now, and it's called the LOD, right? So this is a term that you got to be careful of when they ask you to deliver a 3D model. And let me go back to my PowerPoint to show you this. This LOD is that they will ask you that for example, for 60% submittal, you need to submit the model on LOD 300. These parameters are predefined. So with LOD 300, you need to provide your bridge with every beam located, right, geographically. So it has to have the real coordinates, all the physical properties, and the exact representation. So your astro beam has to look like an astro. So if they ask you for that, you know that right off the bat, you get LOD 300 with OpenBridge Modeler. Now, going back to this, with LOD 350, now you need rebar in 3D, right? So in Florida, for example, if I'm not mistaken, if you deliver something in LOD 350, you may need a minimal set of plans. There's no need of plans that much. But then for that, you need to detail your rebar in 3D. And that could be quite challenging if you don't have the right set of tools. Now, in OpenBridge Designer, OpenBridge Modeler, let me go back to a wireframe model. We have that tools, which you can switch to our ProConcrete workflow and just start your detailing in 3D. This is the concrete elements, done. And then I need to copy that to all the other ones. So just go back and say, clone, create a new template. Let's see here, I need this, and I need this. Right? So typical structures could be done very quick. Or if it's more elaborate, yes, you need to know a little bit more of ProConcrete, because these are the tools that we use. Right? So you can just select concrete again and detail it, change the number of bars, for example, here, and you will see how it's going to change. You got more bars now, and accept the design. And then you can just say, well, I need to know the bar quantities. So I can do a very quick selection set of what I need to know, add it to the set, and these are the bar quantities that I have and the length. Now, if they ask you full detailing of that with labeling, yes, on that, I would say you need a ProConcrete license. But these are enough tools to give you a very quick head start on your design. So, as a, I would say, to end this, just to give you a better idea of what's included on how it works, right? We can say that in that entire workflow, right, if I go back to my PowerPoint here, is that this is what you need to do a bridge. Basically, you need OpenBridge Designer, that's it. Now, for more detailing on production, yes, you will use OpenBridge Designer, but then you will need a full Pro Structure license to create detailing plans, okay? Detailing plans. If it's only 3D, OpenBridge Designer will do it, right? So I would say this illustrates for you the whole 3D delivery solution that DOTs are looking for now. And well, if it's and that's all I have for you. Again, I think we can pass to question and answers. And thank you for giving me your attention.
All right. We've got a few questions that came through the chat, Alex. Go back through these. So question is, how would you show the 2D elements on plans if the OpenBridge modeler design seeds are both in 3D?
That's a good one. I'm still presenting. Very good. Well, the good thing about a 3D model is that, let me switch to top view, right? So remember now, in in our workflow, we have the models, right? Yes, this model is in 3D, right? But remember that we can have the drawing models and the sheet models, of course, they are in 2D. So what we can do here is, I mentioned to you that we can extract a typical section. Well, you can just do that as well. Select the alignment, and I want to cut a section right here. This is the scale that I want to use, and then it will create a drawing module for that, right? And that's it. That is a 2D view. But the beauty of that is that all these elements are part of the model. So, and they are automatically created, and they are a reference file of the 3D model. What does it mean? That if you change the design, the drawing will change automatically. And the sheet that is created, it's just also another reference file, right? That what you can do is just apply reference file operations, like move it and feed it into your sheet. Now, this will apply not only for the typical section, for example, but it recognizes that, for example, you got a footing here, or you have an abutment here, right? So then you can ask for a substructure drawing and say, this is the abutment, created for me. And it will cut enough views to do that. Right? Now, how does he know that he has to do all of this, right? I mean, look, he has done what? All these views. How does he know? Well, you set it up and say, I want it to be auto dimension as much as you can, right? And then I want to see top view, right view, and bottom view. So it does it automatically. And when I mentioned that this information change, look, 5 feet deep, right? Of the abutment here. So let me go back to the model. And this was the abutment, right? So let me rotate it a little bit. So I'm going to go to the abutment. I'm going to ask to be modified. So I'm going to go to the template, right? And it was 5 feet, right? So it's 60, let's do 72 inches, right? Change, accepted. So the abutment is changed. Let's look at the sheet then. Done. That's the beauty of that. How many times sometimes we have to change many different sheets because we made this change. And see in what detail this 72 inches shows up. Well, you don't need to worry too much about it now. So, well, I think that I hope that answers your question.
Yeah, absolutely. We've got another question. I see Oak's got quite a few questions, so I'll bounce between. We have another question from somebody. What is the difference between OpenBridge Modeler and OpenBridge Designer?
Very good question. Well, the big difference is that with OpenBridge Designer, this is the one that I'm showing you, OpenBridge Designer has the options of doing the modeling and all the analytics. If you have OpenBridge modeler only, well, you can only do the 3D model, right? You cannot do the design part of it. So in an organization, you could have a mix of OpenBridge Designer for your structural engineers, right? Because they still want to calculate. And then also a mix with OpenBridge Modeler just to use the modeling part and MicroStation. Because remember, here in Modeler, you also have MicroStation, so it could also replace a MicroStation license with the advantage of having a bridge modeling tool there, right? But in general, I would say what we are recommending for the DOTs in general is to have the designer, right? Because you can design as well. But as a consultant, you can have a mix of designer and modeler. At the end of the day, he manages a DGN file. So.
Gotcha. Okay, another question for you, Alex. Do you have abutment MSC templates and slope protection in OpenBridge Modeler or Designer?
Not right now. I mean, the slope protection in Florida, we call it the aprons around the abutments. We do it now with OpenRoads. OpenRoads is the one that does it right now. Bridge, we don't yet. We have certain tools, but OpenRoads does it better. And then I think the same way will be that what happened with the retaining walls on the side of the bridge, it's OpenRoads that does it.
Okay. And then also for the footings, as you were showing them, are you able to set how deep those are, or are you able to target maybe an existing surface?
Perfect, yeah.
How does that work with the footings and knowing where those
Sure. Yeah. Again, this was a quick demonstration, right? We can go into great details, but then here on the abutment itself, right? When I did it that quick, I can go with the abutments here and I can activate elevation constraints. And these elevation constraints mean that I can target, for example, existing ground that I have it. So I can say my footings, let me go big, 20 feet below the ground and activate it. And that's it. That footings now are 20 feet below the ground. And how does it know that? Because here I have my terrain active, right? So the terrain is active, so it's able to target the ground. So right here. So what happened is I was not displaying that. So I can just go one more time. And as the terrain is active, I can say elevation constraints. I can key in an elevation, or I can say again, 20 feet below the ground and see what happens. Right? So this will change and update. Right? And the ground, I can just target it and activate it here. Okay? So if I render it, now you will see that the ground will be there. It's just way above the bridge. So we can do that. Yes, there is option to target or target elevations too. Okay.
All right. Do we have any other questions? Feel free to type it in or unmute yourself. All right. I think we got a question in the IM. How does it handle spiral curves in the model? Does it take roadways profile alignment files and is able to handle the geometry of the superstructure and the substructure? So is it able to use alignments from open roads?
Actually, that's what I was using, right? Remember, this is the alignment that came from open roads. And that's what I use for the bridge. So all that information is being used by OpenBridge. I just remember, I told you at the beginning that I'm referencing the geometry coming from open roads. So whatever geometry, could be a straight line, or could be a compound curve, or could be a spiral, right? So these can be done. We just read the geometry coming from open roads. See? And that is, for example, the profile of that alignment. So that is directly from open roads. Now, since this is a reference file, of course, I can modify it, but it's coming from open roads directly.
All right. Do we have any other questions? We got another question. Can you model culverts and head walls in OpenBridge Modeler?
I would say no. On the other hand, people are, officially no, right? But then there's always stuff that you can do, because what our users are doing, if you go to this library, right? So you can define a beam, right? That basically can look like a culvert. So you can define a box, actually, and just make it look like a culvert. You here, Astro box. That's your culvert, for example. Right? So you can do that and follow the alignment. So it's not a beam, but then you can extrude it and do that. People are doing tunnels as well. So it can be modeled, but that's all, as I said, we officially no, because the next step will say, oh, let's design the culvert. We don't do that.
But
it can be modeled.
Not a design.
Yeah, but it can be modeled. Look, that's a culvert right there, if you want. Right? So you can create a section and extrude it like that. Right? Or even better, you can say it's kind of a deck type and say, well, that could be kind of a culvert too, right? Just modify the template and make it look like a double barrel culvert, for example. Okay, there is always a trick.
We have a question. So if roadway alignment changes horizontal, vertical, does OpenBridge Modeler automatically update?
Yes, yes. If you, I cannot modify it here. I gotta go to open roads. But yeah, if the alignment or profile changes, then as is attached to a reference file, the reference file here will show a little pencil that says, it will show a pencil here that says that the geometry has changed. And then you will just go and say, reload the file. And as you reload it, the new profile takes over, and then your bridge will just go up or down. The alignment too. Right? And even if the corridor changes, right? So for example, here, if I go in top view, and then, for example, they extend the corridor and your bridge limits are no longer valid. So you can always go here. I mean, that would be the easiest way. Right? And then this is, well, it's not maybe 360 or 30 plus 60 anymore. Maybe the new station is, let's see, plus 80. Right? Accept it, and then you will adjust your bridge limits. It will adjust the bridge automatically too. Right? So it can do all of that for you, still updating. So it reacts to changes. Again, that's another beauty of that all work is interconnected. And then, of course, as I move the bridge limits, right, it's reading the new profile information, you see? So now it's shorter because maybe they modify the coordinate. And new quantities are in place, new deck elevations, and so on. And you don't need to do anything else. I mean, the whole abutment adjusted already, and the beam seats and everything else is already adjusted. I can move basically anything I want.
Alex, are you able to model bridge approach slabs using OpenBridge Modeler?
Yep. Yeah. I mean, what we do is that, you know, we don't have a tool per se that says approach slab, but what we do is we add another support line and we place a deck. So that will be your approach slab. It could be of different thickness and so on, but it will be another deck. So it will be, we treat it as like another span of the bridge that doesn't have any supports. That's how we do it.
Okay. And are you able to convert ORD templates to OBM?
No, that no, that no one. The ORD template is an ORD template, and OpenBridge template is an OpenBridge template. Okay. It's almost the same technology. I have to say that, but then the behavior is quite different because we not only make it a solid, but we add enough properties to make it analytical. That's why we can send it to LEAP or RM.
All righty. Well, it looks like we got 1 o'clock here. So, Alex, appreciate you presenting today. Thank you to everyone else for joining our Tech Talk. We'll be sending out PDF credits shortly. Today's Amazon card winner is David Garrett. So I will we'll be sending you information shortly on how to get that. Again, thank you for attending our Tech Talk, and thank you, Alex, for presenting. And we'll look forward to seeing you next time. Thank you.
No, thank you. Thank you so much. Thank you for your questions. Take care, guys. Thank you.